Scene script. Have you ever pondered on the true nature of reality? A simple question, yet the answer lies at the heart of one of the most complex fields in science: theoretical physics. This discipline is a journey into the deepest corners of the universe, an exploration of the fundamental nature of reality itself. But what does that mean, exactly? What is this reality we speak of? Well, reality is everything that we perceive around us. It's the air we breathe, the ground beneath our feet, the stars in the sky. However, theoretical physics suggests that this reality we perceive might be just the tip of the cosmic iceberg. What if I were to tell you that what we perceive as real might not be the complete picture? That's where quantum mechanics comes into play. This branch of theoretical physics has been described as the wild child of the scientific world. It's a theory that both baffles and fascinates, challenging our conventional understanding of the universe. Quantum mechanics tells us that particles can exist in multiple places at the same time, that they can teleport through barriers, and that their properties can be mysteriously intertwined, no matter the distance. These quantum phenomena seem to defy the laws of classical physics, the very laws that govern our everyday experiences. They suggest that the world at the quantum level operates under a completely different set of rules. Rules that are strange and counterintuitive. This has led some physicists to propose that our perceived reality is merely a facade, that beneath the surface the universe is a lot weirder than we could ever imagine. So what does this mean for us and our understanding of reality? It means that we have much to learn, that there's a vast, uncharted territory waiting to be explored. It's a reminder that the universe is far more complex and far more fascinating than we could ever conceive. But how does quantum mechanics challenge our perception of reality? This brings us to our next topic. Imagine a world where a particle can be in two places at the same time. Welcome to the realm of quantum mechanics. In this fascinating world, particles behave in a way that defies our everyday understanding of reality. This is due to a principle known as quantum superposition. You see, in the quantum realm, particles don't exist in one state or another, but rather they exist in all possible states at once. This is a bit like saying that a coin, when flipped, doesn't just land on heads or tails, but on both at the same time. Let's put this into perspective through the famous double-slit experiment. When particles of light, or photons, are fired at a plate with two slits, an interference pattern emerges on the screen behind it. This pattern suggests that each photon, despite being a single unit, passes through both slits simultaneously, interferes with itself, and creates multiple bands of light. A result that is only possible if the photon is in two places at once. Now you might be thinking, this sounds like something out of a science fiction novel. But it's not. Quantum superposition has been repeatedly confirmed through experiment and observation, making it a cornerstone of quantum mechanics. Yet, this concept stands in stark contrast to the laws of classical physics, which govern our everyday world. In the realm of the large and macroscopic, a thing cannot be in two places at once. If you throw a ball, it follows a single path. It doesn't simultaneously take every possible trajectory between your hand and its destination. But here's the kicker. Quantum particles aren't just tiny balls. They're both particles and waves at the same time. And it's this wave-particle duality that allows them to exist in multiple states simultaneously. So, we've seen how quantum mechanics challenges our understanding of reality. It presents a world where particles can be in several places at once, can pop in and out of existence, and can even affect each other instantly over vast distances. So, if quantum mechanics defies the rules of classical physics, then what rules govern the quantum realm? In the quantum realm, uncertainty is the only certainty. Now this might sound like a paradox, but it's actually a fundamental principle of quantum physics known as Heisenberg's uncertainty principle. Let's dive a bit deeper, shall we? Picture a tiny particle buzzing around at breakneck speed. According to classical physics, we should be able to measure both its speed or momentum and its exact location simultaneously. But quantum physics throws a spanner in the works. It tells us that the more precisely we measure one of these quantities, the less precisely we can know the other. This is not due to any limitations in our measuring devices. It's a fundamental aspect of quantum particles themselves. They're elusive, always keeping a bit of themselves hidden from us. This principle forms the foundation for the unpredictability and randomness inherent in quantum mechanics. It's like a cosmic game of hide and seek, where particles pop in and out of existence, teleport through barriers, and can even be in two places at once. But why does this matter? Well, it's this inherent uncertainty that allows atoms to exist, light to shine, and life to flourish. Quantum mechanics underpins everything around us, from the functioning of our technology, like smartphones and computers, to the workings of the sun, and even our own biology. Remember, in the quantum realm, there's no such thing as a passive observer. Simply by observing, we change the outcome. It's a world that defies our everyday intuitions, a world where nothing is as it seems, and where uncertainty is the only certainty. Quantum mechanics may seem strange and counterintuitive, but it's a theory that has been tested and proven time and again. It has stood up to rigorous testing and has made predictions that have been verified to an astonishing degree of accuracy. So, as we delve deeper into the world of quantum mechanics, we find that our understanding of reality becomes less about concrete facts and more about probabilities and possibilities. Now, let's venture even deeper into the theoretical. What if the fundamental particles of the universe were not points but tiny vibrating strings? Picture this. Instead of imagining particles as minuscule dots, think of them as incredibly minuscule strings. Just as a guitar string can vibrate at different frequencies to create different notes, these strings vibrate to give us different particles. This is the premise of string theory, a theoretical framework that radically reimagines the universe's building blocks. You see, in our everyday world, we're accustomed to things having length, width, and height. But in string theory, we're dealing with objects that only have length. They are one-dimensional. These strings are so tiny that they make an atom look like a colossal giant in comparison. Why does this matter, you might ask? Well, string theory could potentially resolve one of the most significant conundrums in physics. For the longest time, quantum mechanics and general relativity have been like two incompatible puzzle pieces. Quantum mechanics excellently describes the universe on an incredibly small scale, while general relativity brilliantly explains the universe on a massive scale. But put them together, and they clash. This is where string theory steps in. It suggests that these tiny vibrating strings might be the key to unifying these two theories. It's a bit like finding a translator who can speak both languages fluently, facilitating a conversation that was previously impossible. If true, it could offer a unified description of the universe, tying together everything from the tiniest particle to the vastest galaxy. However, it's important to remember that string theory is still just that, a theory. While it offers a tantalizing glimpse into the potential unity of the universe, it's yet to be proven. Like a mystery novel, we're still waiting for the final chapter to reveal if the clues all add up. While string theory is still a theory, it offers a tantalizing glimpse into the potential unity of the universe. So, what does all this mean for our understanding of the universe? Theoretical physics, with its intriguing branches like quantum mechanics and string theory, is like a unique lens, a different perspective, through which we can view and comprehend the cosmos. It's a bit like trying to solve a jigsaw puzzle, but with each piece representing a fundamental law or principle of physics. As we delve deeper into these theories, we're not just fitting together the pieces of the puzzle, we're also reshaping our understanding of the universe. Quantum mechanics, with its paradoxically minute and immense influence, has already shown us that the universe is far more bizarre and unpredictable than we could have ever imagined. It's a world where particles can exist in two places at once, and where observing a phenomenon can alter its state. And then there's string theory, that enigmatic concept which suggests that all particles are composed of one-dimensional strings. This theory could potentially reconcile the rift between general relativity and quantum mechanics, creating a unified theory of everything. Yet these theories are but the tip of the iceberg. The universe is still full of mysteries waiting to be unraveled. Dark matter, dark energy, the origins and ultimate fate of the universe. These are just a few of the enigmatic questions that theoretical physics seeks to answer. But remember, the quest for knowledge is not a straight line. It's a winding path filled with detours, dead ends, and sudden illuminating discoveries. It's a journey that requires patience, curiosity, and above all, an insatiable hunger for understanding. The universe is a vast, complex, and fascinating place, and theoretical physics is our key to unlocking its secrets. It's a tantalizing realm of infinite possibilities and unexpected connections. So, Keep questioning, keep wondering, and keep exploring, because that's the beauty of science. This quest for knowledge, this desire to understand the fundamental workings of the universe, is what propels us forward. It's what makes us human. It's what makes us us. The universe is a vast, complex, and fascinating place, and theoretical physics is our key to unlocking its secrets. So keep questioning, keep wondering, and keep exploring, because that's the beauty of science.